Welcome back. In the second presentation on the FABLE Calculator, we will look at how to get started with this FABLE tool. We will begin with a brief recap on Excel tables and the main formulas used in the calculator. After that, we'll have an overview of the structure of the calculator to better understand how its different components interact. Excel plays a key role in the FABLE calculator because they help us organize and simplify data. They have a unique name for easy reference, automatically apply formulas across all rows, and recognize and maintain column headers. To create a table, simply select your data and press Ctrl-T. To easily find a table, use Ctrl-G. Tables simplify formulas and enhance readability. They make formula tracking easier and they reduce errors while improving efficiency. Please remember, in the FABLE calculator, tables are often read from right to left, meaning that columns on the left typically depend on values from columns on the right. Here's an example of a table in the FABLE calculator. It contains various types of information, including the table name, which is indicated in blue and should be the same as defined when using format as table. We also have the table number and its complete name, the description of the variable and unit, and finally at the top we can see where the cell contents come from. In this color-coded section we indicate where the values originate. These are the essential Excel functions for the FABLE calculator. Let's look at them one by one. The SUMIFS function is widely used in the calculation sheets to extract specific values from data tables based on multiple conditions. It sums values that meet defined criteria, such as specific product, year, or scenario. In most cases, only one value matches all conditions, meaning that the sum contains just one term. In this first example, we want to sum the values in the column harvested area for the values equal to maize in the crop column and the values equal to 2020 in the year column. Clicking on the formula allows us to better understand its components and see what each item corresponds to. This helps in tracking calculations, identifying dependencies, and ensuring the formula is correctly applied. In this particular case, we're trying to sum the productivity shifters from the table live productivity def, where the animal is cattle, the product is beef, and finally the year is 2000. Let's apply the function to this particular cell and see how SUMIFS operates. The first element the function identifies is the table, live productivity def, and the column productivity underscore shifter, which contains the data to be retrieved and summed. The second element specifies the first condition. The animal column in live productivity def must match the animal in our row, which in this case is cattle. The function automatically filters the live productivity def table to include only rows where animal is cattle, excluding all others like chicken. The third element defines the next condition. The F product in live productivity def must match at F product, which in this case is beef. This ensures that only data related to beef is included in the sum, filtering out all other products. Finally, a third condition is applied. The year in the live productivity def table must match at year, which in our cell is 2000. Once all these criteria are applied, the function returns the productivity shifter, which in this case is 1. The VLOOKUP function is used to search for a specific value in one column of a table and return the corresponding data from another column within the same row. It is commonly applied in the FABLE calculator to retrieve information based on predefined criteria. By specifying whether the match should be exact or approximate, VLOOKUP helps efficiently extract relevant data from large data sets. In this example, we're looking for the value maize in the first column of the yield potential table and retrieve the value in the corresponding row in the second column. The match function returns the position of a lookup value within a row or column. It doesn't return the value itself, but its relative position in the range. In this example, the match function looks for the value in the current row's animal column within the animal column of the map animal FAO emiss table. It returns the position where the value is exactly matched. The index function returns the value from a specific row and column in a range or table. It is often used in combination with the match function. In this example, it uses the results of the match function to find the correct row in the animal underscore globium column of the map animal FAO emiss table. It returns the corresponding value from the column where the animal matches. Let's take a closer look at this example. Our goal is to retrieve the value from the animal underscore emiss column in the map animal table that matches the current row's value in the animal underscore globium column. The first part of the formula refers to an index function. It tells Excel to look into the animal underscore emiss column of the map animal table. This is the column from which we want to retrieve a value. The second part of the formula refers to a match function. This function tells Excel to look for the value in the current row's animal underscore globium column. It searches within the map animal in brackets animal underscore globium column and returns the row number where it finds an exact match. In this case, it returns 2. Therefore, our entire formula simplifies to this. It then returns the second value in the animal underscore emiss column, which in this case is BOVO. The if-error function is used to handle errors in calculations by returning a specified value when an error occurs. In the FABLE Calculator, it helps to ensure smooth computations by replacing error messages with predefined results, such as 0. This function is particularly useful for maintaining data consistency and avoiding disruptions in calculations. In this case, the function is looking for the cell A33 in the spreadsheet FAO underscore prod underscore C. In case this cell corresponds to an error, the value displayed will be a 0 instead of the error. Let's take a look at an example of the if-error function. The objective here is to sum the values from the current row hist live CO2e and hist crop CO2e and return a blank if an error occurs, such as missing data or invalid entries like text. If you look at Evaluated Formula, found in the Formula tab in the ribbon, we can see that both values are numeric. The sum of the two columns is 14.8. Since there is no error, the formula returns this numeric value. Now let's consider the same column, FAO total CO2e, but for the corresponding year, 2025. The formula evaluation tells us that an error #value is identified. In fact, both hist live CO2e and hist crop CO2e contain an error due to the lack of historical data for 2025. Therefore, the formula will return a blank instead of displaying the error value. Right, let's get to the fun part. The FABLE Calculator is structured with multiple spreadsheets, each color-coded to represent different sections. In dark red, we have a welcome sheet. This section introduces the calculator, provides country information, and includes licensing details. In blue, we have a changelog, which is essential for tracking any modifications made to the calculator. Then in light red, we have the scenarios section, where you can select, create, and combine different scenarios to design a pathway. In purple, we have the Senathon report tab, where the final results are presented at both product and aggregate level. In yellow, we have the main outputs and indicators sections, which includes tables and plots that help interpret results. In green, there are the calculation sheets, where all the calculations take place, and finally, in gray, we have the data sheets, which provides the data used in the calculations. There are also auxiliary sheets where the raw data is stored before being organized in the gray data sheets, which supply the values for the calculations. One of the most important sheets, especially when designing the pathway, is the pathway selection sheet. Here you simply place an X in one of the pathways to select it. Once you have selected a pathway, you can then choose from 22 predefined scenarios related to factors like GDP, population, or diets. Of course, if you prefer, you can also design your own custom scenarios in the scenarios definition sheet. Let's take a look at how to do that. Typically, for each scenario, we have two tables. On the left, there's a table in which we can add and create other scenarios, and on the right, there's a table that will display the impact of the scenario chosen in the pathway selection sheet. The first step is to add a new row to the table, crop productivity target, which is the table on the left. Give the new row a name, for example, high growth. Here we have our new scenario for crop productivity. In this scenario, we have a yield gap in 2050 of 20% for all crops, of 15% for corn, and 15% for rice. The next step is to include the new scenario in the scenarios selection sheet. To do this, go to the table corresponding to our scenario, in this case crop productivity, and add a new row. The row name in crop_sen should be exactly the same as the one used in scenarios definition just before. Then add a description and make sure that the formula in the selection column matches the one used in the other rows. This step is essential to making the new scenario available as an option in the pathway selection sheet. Now the new scenario has been added to the available scenario options. As a final step, go back to the pathway selection sheet and choose your new pathway from the list. The changes should have been automatically applied. To ensure everything is working, head back over to the scenarios definition in the table crop productivity def and check how crop productivity will evolve by crop for our new pathway. All new scenarios follow the same logic, but each one may have its own specific features that require slightly different steps. Right, so let's examine the impact of the shift in crop productivity. In the first graph, we have GHG emissions by sector under a no-growth scenario for crop productivity. In the second graph, we have applied the new high-growth scenario for crop productivity. So in the second graph to the right, we can see that emissions from deforestation are lower in the new scenario, as it would lead to a reduced expansion of croplands into forests. We also see that emissions directly from crops are reduced. So as you can see, many changes can be made to the calculator, and it's really essential to track all modifications in the change log sheet. This is important for many reasons, notably because it can simplify error tracking when changes are introduced. It can enhance collaboration when multiple people are working on the same tool. It can make it easier for the secretary to provide support. And finally, it can help to recognize each person's contribution over time in developing the tool. Well, thank you for tuning in. We hope that this has been helpful and that you now have a better understanding of the structure of the FABLE Calculator and are starting to grasp how to select scenarios and design pathways. If you have any questions or need assistance, please don't hesitate to reach out to us. If you are new to this FABLE tool, we have another video called What is the FABLE Calculator, which you may also find a helpful resource. Thank you.